Okay, in this podcast I'm going to do number 4, 5, and then 2 from Quest for Chapter 4. Okay? Now all of these problems are similar in that they all involve doing stoichiometry with molarity. And this is the area that students struggle with the most with stoichiometry. And what you got to remember is that molarity is moles of solute over liters of solution. Okay? And if I know that, then I also know that moles is going to be molarity times liters. It's also important to remember that 1 liter is 1,000 milliliters. A lot of these problems were given milliliters. Okay, so let's take a look at number 4. And we'll do 2 last, which is the easiest. Alright, so for number 4, it says we add excess sodium chloride to a solution of silver nitrate to form insoluble silver chloride. When it has been dried and weighed, the mass of silver chloride is found to be 2.83 grams. What's the molarity of the original silver nitrate solution? Okay, so the most important thing to do whenever you have a problem like this is always write a balanced equation first. So I have silver nitrate, sodium chloride plus silver nitrate gives me a solid silver chloride. And I always like to write what I'm given and what I'm trying to figure out so I'm really clear about the problems I'm trying to solve. Okay, so let's do the stoich. We know we have 2.83 grams of silver chloride, so that's what we're going to start with. Okay? So if I have 2.83 grams of silver chloride, I know its molar mass. I know that 1 mole of silver chloride based on the balance equation gives me 1 mole of silver nitrate. And if I plug and chug, I get 0.0197 moles. But I also know that molarity is moles over liters. And I know I have 0.0197 moles. I put that over, I've taken the 43 liters and converted it to milliliters, and I come out with 0.459 molar. Okay, let's try number 5. Okay, similar problem. It says we add excess sodium chromate solution to 42 milliliters of a solution of silver nitrate to form insoluble solid silver chromate. When it has been dried and weighed, the mass of silver chromate is found to be 0.52 grams. What is the molarity of the silver nitrate? So again, we want to start with the balanced equation. And when I do that, you are going to need 2 sodium nitrates and 2 silver nitrates. I write down what I know and what I'm trying to find, and then I do my stoich. So I'm going to start with my 0.27 grams of silver chromate. And in this case, I have to recognize that I have 2 moles of silver nitrate for every 1 mole of silver chromate. But I know how many moles of silver nitrate I have. And I'm going to put that over however many liters I have. I got 14 milliliters, which is 0.014 liters. And that comes out to be 0.746 molar of the solution. Okay, let's take a look at number 2, which should be the easiest. Number 2 is we have silver nitrate reacts with sodium chloride as indicated. We already have the balanced equation. Everything is balanced. How many grams of sodium chloride would be required to react with 419 milliliters of 0.56 molar silver nitrate? Okay, so what we are given is the grams of sodium chloride. We know the molarity and the number of milliliters of silver nitrate, which means we can determine what the number of moles of silver nitrate is. But let's go ahead and start with the 419 milliliters of the silver nitrate. I'm going to convert my milliliters to liters, and then, this is the factor that I'm going to use here because this is my molarity factor. 1 liter of silver nitrate was 0.506 moles. I know that from the 0.506 molar. That's what it tells me. I have 0.506 moles for every 1 liter of solution. In this case, it's a 1-to-1 mole ratio. And I have the molar mass of sodium chloride, and that comes out to be 12.39 grams of sodium chloride. Okay, I'm going to stop right there.